Okay. Well, admit all. Okay, do we have everybody here? If you are not here, please raise your hand. Yeah, I think that's everybody. So I'll just paste the Nearpod link again. If you could. Actually, somebody raised it. Okay. And let me share my screen now. Okay. So can everybody hear me very clearly? Com check.
Yep.
Okay, good. Thank you. Let me see the checklist now. Okay, if you could please join my Nearpod link, and so we'll start. Welcome to the heat and phase transfer session. Today we basically will summarize the heat transfer mechanisms, and we'll later link them to the phase transfer and the lasers. So please know the session will be recorded. And a few very simple ground rules is that please mute when you're not talking. Please be active in group discussion and respect others' opinion and give constructive comments. And last but not least, no pressure at all. So if you agree to these ground rules, please give me some reaction. Thank you. Right, so something about me. My name is Wen He, and I'm a scientist too in the SimTech. My research interests include laser material processing, also the use of laser for repair and remanufacturing, and also I'm starting to pick up some design for manufacturing for laser-based processes. So to start, I would like you to do a little bit of challenge. I would like you to link the 3 heat transfer mechanisms to the correct picture. So please click on the screen. Okay, I'm getting the results. Let's link the heat transfer mechanisms to the correct picture, which you think fit. Okay, I think everybody's doing a good job. Everybody got 3 out of 3 matches, except somebody experienced a little bit more tries. So I think the correct relation is that radiation is related to sunbathing. You are absorbing the energy from the sun itself. And convection, you are using the hot air, which is basically a flowing fluid to quickly conduct heat to your hair and have it dried. And finally is the conduction, like a hen incubating her eggs by sitting on the eggs for a prolonged time so that the temperature will be kept all right for the little chicks to pop out later. Very good try, guys. And next one, we'll do some recap. So about the heat transfer, we introduced the async session. Basically, we have 3 mechanisms. Conduction is the heat transfer via direct molecular collision. And then is the convection, which is the heat transfer via the movement of fluid. And lastly is the radiation, which is the heat transfer via electromagnetic wave. And another recap is the answers of the quiz. I think most of us have managed to get the answers correct. So the first question is, which of the solid material has the lowest thermal conductivity? The correct answer is the plastic, and compared to the rest of the 3, which are metals, this one has the lowest thermal conductivity, marked as K. Next question, which isn't an example of the convection? I think one of us got this wrong, but the correct answer anyway is the steel plate for teppanyaki barbecue because the heat transfer relies on direct contact of solid materials. And lastly, radiation doesn't require medium to transfer heat, considering the vast space between us and the sun, which is basically vacuum. The radiation doesn't require medium to deliver heat to the earth. All right, next recap is the K and the material choices. I do read your comments. I think I have some very interesting comments. So can I have Aloysius to do the first one for us, which is which material would you choose for the rifle grip?
I think something heat resistance because it's gonna be high heat when you shoot. So lightweight would be good, like plastic, like thermoset plastics. So would be nice.
Okay, thank you. And then for the electronics heat sink, can I have Jasmine to provide with us your thoughts? Which kind of material would you choose?
Okay, so we want something with a high thermal conductivity also, and probably something lightweight if it's going to be used in a portable device. So I chose aluminium.
Jolly good. Thank you very much. And lastly is the so-called down jacket. Can I have Wei to describe us what kind of choice would you make?
So I'd like to choose like feathers or cottons. Yeah. For the jacket because they are lightweight and also they are good thermal insulator. So you will keep your body warm.
Okay, very good.
Yeah.
So these would be my picks. There are no standard answers, so these are my thoughts. So normally I would pick low K materials to shield the barrel's heat because when you're shooting, it generates a lot of heat. And for the gun stock, I also choose the low K material because if you use it in winter and put your face on that, it won't be too comfortable if you use metal. And materials, I would like to say wood or plastic such as polyamide are good picks. And for the heat sink, indeed, mostly is aluminum because it's number one, metal with a high K. Number two is lightweight, and last but not least is cheap. And lastly, for the down jacket, you would like to fill some fluffy and lightweight material to keep the air inside. And the air has a rather low thermal conductivity, so you use that air trapped inside to keep you warm. And under the jacket, you may also consider polyester or wool or cashmere, which are indeed also fluffy materials to keep you warm. All right, then the last slide of the recap in the async is the calculation. So I won't go into details. I just want you to notice the difference in the order of magnitude. So if you rely on the thermal conductivity, it gives you something less than 50 watts, which is basically the same as me sleeping. So when I'm sleeping, I have the lowest power generation, which is less than 50 watts. And then the heat, the convection takes away is so much higher. You see it's over 2 kilowatts, and this is basically equal to a, say, Kylian Mbappe charging. So he's the top athlete, and 2 kilowatt is something of his peak power output. And then if you rely on radiation, you have something around 1 kilowatt. And this is similar to the sprinting power of the professional cyclists in the Tour de France. So the point I want to make here is that three mechanisms can take away the heat in very different order of magnitude. Okay, so allow me to introduce the main course today, which is the phase transfer. And it's something commonly happening in the laser matter interaction. So when you have a focused laser shine on the surface of some solid, you will have heat transfer, and this will induce the phase changes, including melting, vaporization, and ionization. Sometimes it also involves chemical reactions, but today let's focus on the phase changes. So basically, there are three common states of material we see every day: solid, liquid, and gas. So when solid absorbs energy, it melts, and this is a process that absorbs heat. The liquid can go back to the solid, and this is a process that releases heat. So from liquid to gas, you have the vaporization. When liquid absorbs heat, it eventually becomes gas, and the reverse process is called condensation. Gas to liquid, and it's releasing heat. And you also sometimes have directly change from solid to gas and vice versa. This is a pair known as sublimation and deposition. Next page, there is a quick simulation that I hope everybody can play. So if you can drag the handle at the bottom of the screen and pick the atom or molecules you like. For example, I would use water to demonstrate this. Just confirming with you, can you? Yes, Dr. Im, I see you raise your hand.
Can you reverse one slide?
Yes,
Is there something wrong with your arrows?
there is. Yes, the vaporization should be pointing right and the condensation should be pointing to the left. That is my mistake. I'm sorry, and thank you very much for pointing out. All right, can everybody play with the handle on your own screen? I see somebody nodding. So basically the idea is that you have the water minus 100 degrees, and this is a state known as ice, it's solid, and you can see the molecules still doing some Brownian motion, but still it's remain in the solid framework. And then if you heat it up, which goes up, and you see the structure has been shattered and the molecules are moved more freely. And we are talking about 4 degrees, and this is when the water becomes like liquid water. And if you then heat it up further over 100 degrees, what happens is that you see some of the molecules will go upwards. Okay, the shattered. Now we have the water steam. So this would be a demonstration of the changing of the states between the material from solid melting to liquid, and liquid vaporizes to water vapor. All right, so time for some group discussion. Okay, I'm going to divide everything into 2 groups, and for group 1, I'll put you in this scenario, like, you know, the Earth can be a rough place to live, and in the wrong environment, you can, it can be very dangerous for us to live. So basically, the rule is that you can only survive 3 hours in extreme heat or cold. You can survive 3 days without drinkable water, or you can survive 3 weeks without food. So for group 1, I would like you to describe me 2 survival skills you have heard of and relate them to the right phase transition. Okay, 2 survival skills and what kind of phase transition you would like to employ. Okay, and then for the group 2, imagine you are working for a jewelry shop which does basically repair and customization of jewelry, and your boss recently bought a 100-watt nanosecond green laser, okay, with a microprocessing setup. You can focus the laser and you can scan it around. And your boss now wants you to explore what kind of job it can do for the shop. So I would like group 2 to name 3 applications that you can think of and relate them to the right phase transition. So now I'm gonna divide everybody into 2 breakout rooms. So first group, I will have Aloysius, Chuan Kai, Xin Ying, and Dr. Im.
I don't think I want to be in group 1. Very
Okay,
boring
absolutely.
talking about the Earth. Yeah, I like to talk. I want to go to the jewelry shop.
Okay, right. Then I will put Mill to the group 1. And then for the For group 2, I'll have the rest of you to be in the group. And now we'll open the rooms for, say, 5 minutes. Hope it's all right. And then more rooms. Please join.
Hello.
Can you see the tablets already?
Yeah.
Yes.
The palette page, yeah.
Okay. Just a little bit of hint that survival will require shelter, first aid, water, fire, and food to start with. So anything you have thought of and anything you can Google right now, see some Bear Grylls trick, and then you can put down what you think about the phase transfer they would like to try.
Okay.
I think engraving also.
Engraving, I don't know. Is this melting? Melting, then
Melting.
condense again. I don't know.
We can ask when her.
Mm.
Yes.
Carry
Okay,
on,
so
carry on, act as if I'm not
melting.
there.
Okay, maybe we put
Yeah.
this
We
first.
put melting first.
Yeah.
Melting or vaporization, actually, I don't know.
Solid to liquid.
Yes.
And for welding, it's central.
Melting
Melting also.
Yeah.
Okay. That's all.
Okay, thank you. Just curious if you can think of number 4 or number 5 of these applications, please carry on while I go back to group 1 and see what kind of weird stuff to do themselves.
Actually, I can think of number 4. We can use laser to like identify if the Jerry is like true one or like the unreal Jerry.
For authentication.
Spectroscopy.
But it's not
that-
about phase transition. Like, it's about like
More authentication.
yeah.
I think one of the trick is that you shine a tiny laser pulse to a blade, like remove a little bit of the metal, and you collect the light. It comes out and see the spectrum, and the spectrum gives you some hint that whether you have other metals in your gold. So if somebody claims it to be 24K gold and you see a lot of zinc in it, it's fake.
It seems need a lot of expensive equipment to identify that.
Indeed, yes. Or I think Archimedes did this something like 3,000 years ago by like put a thing into the water and see the density of the thing. So it's gonna be easy. No laser involved in like 3,000 years ago. Anyway, thank you very much.
Is your hair a result of doing this?
My hair is a result of the Singapore weather. I think I sweat a lot, so losing some hair, so no longer to hide it.
It looks like you're electrocuted or something. You know, your hair is just shows signs of being electrocuted.
Well, I hope not. Otherwise, I will have to report it to the health and safety. Anyway, thank you. I'll see you in the main room.
Okay.
Okay, I see I have an answer from the group one. If I can correct you a little bit, the answers I expect is the phase transition, not the heat transfer. But I see it's a good try. So can you, Xinying, correct a little bit of your answer and link them to the phase transition?
Yeah, I think in the survival scenario, lots of the heat transfer rather than phase transition. For example, like shelter, I don't think there are like phase transitions when we are keeping ourselves warm or we're blocking the sun radiation. So we were thinking like, oh, maybe we go with the heat transfer.
Okay. I think the boiling water is a good example that when you boil the water, what you see is indeed a phase transition, some of the phase
Liquid to
transition
gas,
from liquid
yeah.
to gas, yes. And you can use that to steam the fish or lobster you manage to catch. That's one thing I can think of. Another skill I have heard of that in the desert you need water. So what you do is you dig a hole which is deep enough, and then you put a piece of plastic film or cling film on top of that. So the heat will evaporate the water and the water will condense on this film, so that if you put a little bit of rock in the middle of the film and put another beaker or whatever vessel under it, you'll be able to collect water. Anyway, good try. So shelter-wise, I see not too much sun and keep warm. Indeed, yes, I think it's a good example. Just put your thinking hat on regarding the harsh environment and what kind of physics can maybe save you one day. And then for group two, can I have Jasmine to summarize the findings?
Okay, so we identified first one is to use laser to clean or polish the jewelry. So that is involving vaporization from solid to gas. Second point is to do engraving. So this will be a melting transition. So solid will transit to liquid. And third, we have welding the transition is melting from solid to liquid as well. And the last point is for authentication. So this one doesn't have a phase transition. So we our group was discussing about how we can actually use laser to do like some sort of like spectral scopy to actually detect whether the material is really gold or not.
Okay. Very good examples. Thank you very much. And I think just one thing, if I can put some thought of mine, the second one, engraving, is actually also vaporization, because indeed you remove the material from the solid and turn it into gas to leave that engraved mark on that. So I would consider engraving as vaporization. Okay, thank you, group 1 and 2, and move on to the next page. So we quickly summarize what we learned today. So we had a recap of the heat transfer mechanisms and related them to the phase transfer between the three basic state of the materials. And then we also explore the possibility of laser as a heat source for phase transfer and material processing to make us money. So I think that'll be all. And here's a link of the pics I have taken, like pasted into the material just as a disclaimer. So anyway, thank you very much. And that will be all of my session today. Thank you.
Okay, so next one is singing.
I'll put the link in the chat. Yeah, and which is the same link inside the Google Classroom as well.